right, this is section 13, topic 3. Called Radian Measure Part 1. And the target. How do you convert radians to degrees and degrees to radians? All right, when measuring angles, one way to do so is by degrees. But another way to measure is in the number of radians. One rotation around the circle is 360 degrees. That is equivalent to 2 pi radians. Do y'all know what a radian is? You know what a radius is, right? Yeah. In a unit circle, how long is the radius? What's the distance of each radius? 1. Okay. So what a radian is if you can imagine, here I have a little unit circle right here. If you have this unit circle, okay, and here is a radius, right? If that radius has a length of 1, and you pick that radius up, and say you can bend it, and you put it on the circle, okay? A radian is how many of these radii are around the circle, okay? That's what a radius is. So, a radius is, or pi is approximately 3.14, correct? Okay, so it says all the way around the circle is 2 pi. So 2 times 3.14 is 6 something, right? So that means approximately, you could pick that radius up and it would fit around the circle 6 point something times. That's what that means. That's what a radian is, all right? So when you're talking about trigonometry, a lot of times it's going to be in degrees, a lot of times it's going to be in radians. If it's in radians, you'll usually see it in, like it'll have pi with a number, okay? But sometimes they do convert it to a decimal. So that gets confusing when they convert it to a decimal, because if you see pi, you know it's in radians. If it's in degrees, it will definitely have the little degree symbol. So if it's a decimal form of radians, there won't be a degree symbol. So that's how you can tell. Are we talking about degrees here, or are we talking about radians here? It's two different things. Okay, y'all with me so far? All right. So we need to know how to convert from radians to degrees and degrees to radians. So first thing we're going to do, what is the radian measure at 180 degrees? Well, let's draw us a quick little unit circle. And remember, if you're going counterclockwise, are your degrees positive or negative? Positive. And if you're going clockwise, your degrees are negative, right? So if we're going counterclockwise, this would be at 90 degrees, 180 degrees, 270 degrees, a full 360. But if we're going clockwise, and it's the other way, this is 90, this is always 180, negative 270, I should say negative 90, negative 180, negative 270, negative 360, right? So when we label this today, I'm going to do this in counterclockwise. So we know we start at 0 degrees. We have 90 degrees up here, 180 degrees, 270 degrees, and 360 degrees. And we are already told that a complete rotation, 360 degrees, is equivalent to 2 pi radians. Right? Okay, so let's figure out some other radian measures. If we know a whole rotation is 2 pi, let's figure out some others. So we're going to say, what is the radian measure? At 180 degrees. So complete rotation is 2 pi radians. What do you think it is for half of the rotation? Pi. Just pi, right? So half of 2 pi would be pi. So 180 degrees is pi. And again, we don't put a degree symbol with radians. No degrees. What is the radian measure? At 90 degrees. Any ideas? Half a pi, right? So we know that 90 is half of 180, bless you. So the radians would be half a pi. Well, half a pi, 1/2 times pi, wouldn't that just be pi halves? So that's how we would write it, pi over 2, pi halves. Okay, then, what is the radian measure at 270 degrees? It is 1/2 pi. The way we'll write it is 3/2 pi. Okay, that's how you'll see it. So 3 pi over 2. Because that is 1 whole pi, right, and another half. Or you could say 3/4 of 2 pi and reduce the fraction. Either way, you're going to see it written as 3 pi over 2. So those are kind of easier because we could like figure out the math pretty easy. It's like a whole or a half or a fourth or a 3/4 or whatever. But if you don't, if you had like, okay, at 30 degrees, well, how many pies is 30 degrees? Let me show you just an easy conversion to do. All right, so how can we convert degrees to radians? What you do is you take however many degrees there are and you multiply by pi over 180. Because isn't pi equivalent to 180 degrees? Right? So, for example, when we convert 90 degrees to radians, I mean, we figured that out in our head, but if we use the formula, all we do is we take 90, multiply that by pi over 180. So that gives us 90 pi over 180. And then when we reduce that, 90 goes into 90 equally and into 180. 90 goes into 90 once, 90 goes into 180 twice. So that gives us 1 pi over 2, or just pi over 2, which we say is pi halves. Coolio. Sorry, moving that up and down on you. All right, well, how do we go the other way? How can we convert radians to degrees? So to go the other way, super easy. All you do is, wherever you see pi, you substitute in 180 for pi, because they're equivalent, right? So substitute 180 degrees for pi and reduce or simplify. So how many degrees is 2 pi? We'll convert 2 pi to degrees. So like I just said, so you have 2, instead of pi, we'll substitute 180 degrees, and that would give us 360 degrees. Easy as that. Let's just do a little practice there. And then once we have a little practice, I gave everybody this unit circle. We're going to glue it down on our paper, and we're going to complete the unit circle. If they gave us degrees, we're going to figure out what the radian measure is. If they gave us radians, we're going to figure out what the degree measure is. Okay? But we're going to just do a little practice before we do that. Everybody good? Okay. All right, let's practice. Convert 150 degrees to radians. $150 to radians. So remember, when you're converting degrees to radians, you take your degrees and you multiply by pi over 180. Then you want to reduce, if you can reduce. So my degrees are 150 times pi over 180. So, you know when you multiply fractions, in this case you have a whole number, but we can make it a fraction. Numerator times numerator, denominator times denominator. And you're not going to leave it as 150 pi over 180. You have to reduce that. So on these, I kind of reduce a little at a time. If they both end in 0, I know they're both divisible by 10, right? So I know right off the bat that reduces to 15 pi over 18. And that just made my numbers a whole lot smaller. However, they're still both divisible by 3, right? So 3 goes into 15 5 times. 3 goes into 18 6 times. So 150 degrees is equivalent to 5 pi over 6. So if we were to take our radius out of the circle and put it around the circle, 5 pi over 6 is equivalent to approximately 2.6 radians, or radii. So it'd go around, and you'd fit 1, 2, and about 6/10 more of a radius at 150 degrees. Does that make sense? Okay, so now let's just go the opposite direction. Convert negative 3 pi over 4, so you know that would be a clockwise rotation, into degrees. So remember, to go from radians to degrees, you just substitute in 180 wherever you see pi. So in this case, that would be negative 3 times 180, quantity divided by 4. Well, negative 3 times 180 is negative 540 divided by 4. That does divide evenly, and you get negative 135 degrees. Anybody have a question on that? All right, pretty easy, right? So I'm just going to give you two to try real quick, and then we'll complete the unit circle. Now you try. So number 3, we will convert, or you will convert, negative 225 degrees into radians. And then on number 4, you will convert 7 pi over 6, or 7/6 pi, into degrees. So try those on your own. Let's All right, what did y'all get for negative 225 degrees into radians? Negative 5 pi over 4. Did anybody get something different? Nope, that's what I got too. Okay, so degrees to radians. You know, you take your degree and you multiply by pi over 180. So that gives you negative 225 pi over 180. So I can reduce that right off the bat. I went with negative 45 pi over 36. And then I can see 9 still goes into both. 9 goes into negative 45, negative 5 times. 9 goes into 36 4 times. I can't reduce that anymore, so that would be my final answer. Everybody cool with that? All right, how many degrees is 7 6 pi? 210. 210, that's what I got as well. So remember, radians to degrees, you just substitute 180 for pi. So 7 times 180 is 1,260. Yes?
Do you have Patience Alexander and Samantha Caraway?
I have Patience. I don't have Samantha in this class.
Okay, well, can you send Patience down a discipline?
I sure can. You're welcome. Patience, do you have your phone you can scan out? All right, so that equals 210 degrees. Coolio? Anybody have questions? All right. Should we take this with you? All right, so now take that unit circle that I gave you. Glue it on a separate sheet. And I'm going to just use the whole sheet for the unit circle because they'll give you plenty of room to like just do your math calculations on there. And you want to do them on the sheet so that when you go back, you'll see where you did the calculations. I cut mine into a circle. You don't have to do that. Up to you, but y'all know I'm a little extra. And your pouches should have glue sticks in them. If they don't, there's extras over there on the counter. A lot of people's has more than one. Y'all can share glue sticks. We haven't used them in a while, so they might be a little dry, although I haven't used this one in forever and it's fine. So I want y'all to complete that on your own. And those of you watching the video, it's going to be a lot of silence for this, but everybody's going to do this on your own, and then we'll come back and compare answers in the end. Okay? And I can't pause the video because it'll just stop it completely, otherwise I would, for those of you at home. All right, so we understand what we're doing? If it gives you radians, write the degree equivalent. If it gives you degrees, write the radian equivalent for the whole circle. Last class we found ordered pairs on the circle. We didn't actually put them in on the entire circle, but today we're doing the degrees and the radians. At some point we'll have a unit circle that has everything completed on it. Coolio? All right, I'll be quiet now. Bless you. All right, y'all ready to see mine? Compare it? Pretty close to being finished? Okay. All right, so I color coordinated mine so I knew which section of my paper to look at for my math. So y'all just check mine with yours, make sure that I didn't make any mistakes or you didn't make any mistakes. So in my first quadrant, 0 degrees is 0 pi, or just 0. Pi 6 is 30 degrees. 45 degrees is pi fourths. Pi thirds is 60 degrees. Pi halves is 90 degrees. 2 pi thirds is 120 degrees. 135 degrees is 3 pi fourths, or 3/4 pi. 5 pi over 6 is 150 degrees. Pi is 180 degrees. So that was the second quadrant. Third quadrant, 7 pi over 6 is 210 degrees. 225 degrees is 5/4 pi, or 5 pi over 4. 4/3 pi is 240 degrees. 3/2 pi is, oh, I wrote 3/2 pi. I meant 270 degrees. 5 pi over 3 is 300 degrees. 315 degrees is 7 pi over 4. 11 pi over 6 is 330 degrees. And 2 pi is 360 degrees. Any questions about that? Anything you think I might have made a mistake on? Okay, because I don't have the answer key sitting right here, so just want to make sure. Okay, we have one more thing to discuss, and then I will give you your classwork. Remember, if you need to see my notes afterwards, you are welcome to do so. And of course, they're on Teams, as well as the video of notes will be as well. This has been an exhilarating lesson. Who wouldn't want to watch it again? Right? All right. More unit circle stuff. Consider the unit circle diagram below.
Can we continue these on the notes we took?
Yeah, this is still notes on the same topic. Then evaluate sine of pi over 6. So this you have to know what we did last class to be able to do this. So let's draw us a unit circle. It doesn't have to be humongous. All right, so they want to know the sine of pi over 6. Okay, well, first of all, we have our unit circle. So we know that pi over 6 is 30 degrees, right? So they want to know the sine of 30 degrees. But say I didn't have my unit circle handy. To me, it's easier to think of how many degrees is pi over 6. That's easier for me to think of than where is pi over 6 on the unit circle. So if I didn't have my unit circle handy, I would say, okay, well, I know this is in radians because I see pi and I don't see a degree symbol, right? So radians to degrees, I would just substitute 180 in for pi and simplify. That would give me 30 degrees. So on my unit circle, I'm going to approximate where a 30-degree angle would be. And that's going to be my theta. So remember what we did last class, and my circle's not perfect. So you go to where that ray intersected the unit circle, that terminal side that we drew, and you draw a line straight down so that it's perpendicular to the x-axis. And that's what helps us evaluate sine, cosine, sine and cosine, tangent. So remember, a 30, 60, 90, if you forgot from last class, if this is 30, this is 90, this has to be 60 degrees, right? Remember the side from the smallest angle we call S. The hypotenuse, do y'all remember how long the hypotenuse is compared to the shortest side? 2S. And the middle side is S times the square root of 3. And how long is the length of a hypotenuse in any triangle on the unit circle? 1, right? So we know the length of the hypotenuse is 1. So if 2S is equal to 1, what is S equal to? 1/2. Kind of going over this again because a lot of people weren't here last class. So just a little review. So we know the shortest side is 1/2. And then so what is 1/2 times the square root of 3? Square root of 3 over 2. So the middle side is the square root of 3 over 2. So back in our unit circle, the angle across from the 30-degree angle is 1/2. It's your shortest side because it's across from the smallest angle. We know the hypotenuse is 1. And then the side across from the 60-degree angle is square root of 3 over 2. Now they asked us for sine. So remember, your sine function, sine of theta equals what? Is it x? Is it y? Is it y divided by x? Sine of theta is y. So if I'm just looking for the sine of theta, remember also sine is opposite over hypotenuse. So anything over 1 is just going to be whatever that opposite was, right? So what is the sine of pi over 6? 1/2. Because that's your y value. Also, if you did opposite over hypotenuse, which is what sine equals, right, you would get 1/2 over 1, which is just 1/2. Yes? Did you try that? You got 0.5. We have to be careful because in calculators, especially if it is graphing calculators, sometimes it'll be in radians, sometimes it'll be in degrees, and sometimes it just does weird stuff. So I don't like to count on that because I'm afraid that it's going to be in the wrong unit of measurement and give me the wrong answer. So, and on your assignment, I want to see your work. Because that's how I roll. Because otherwise, just playing the calculator, you don't know what it means. You know what I'm saying? If you just do that every time, you have no concept of what does this actually mean? What am I actually finding? So, all right, one more of these, and then I'll give you an assignment. So on the next one, we're going to evaluate cosine of pi 6. Well, what's the trigonometric function for cosine? Cosine equals what? Cosine of theta equals x. So do we already know this information? Yes. The cosine of pi over 6 is what? The square root of 3 over 2. Thank you. Oh, make sure you scan back in, the big one. All right, so can we also determine the coordinates of where our terminal side met the unit circle? What would that be? Exactly. So determine the coordinates of where the terminal side intersected the unit circle. So we know that's x comma y, right? So our x was square root of 3 over 2, also known as our cosine. Our y, our sine, was 1/2. And because that was a positive pi 6, we know that it was rotating counterclockwise, because if it was negative pi over 6, then we would have to go clockwise, right? Are you going back?
I guess that's the rest
Okay. Anybody have questions on that? Everybody? Okay. Let me pause this and then we will do assignment.